Hi everyone, welcome back to PRAKASAM tutorials. In this video, I am going to discuss about band limited white noise. In my previous video, we have discussed about concept of the white noise. A white noise whose spectral components are finite over a band of frequencies and zero at other frequencies is called a band limited white noise. It is also called filtered white noise. So band limited white noise is also called as filtered white noise. For a signal processing, a band limited white noise is considered for a specified frequency range. Low pass band limited white noise can be determined by applying the white noise through a low pass filter with bandwidth omega naught. Having the transfer function is given by h of omega is equal to 1 for minus omega naught to plus omega naught and h of omega is equal to 0 otherwise. So this is the definition of transfer function of the low pass filter mathematical expression. Similarly, for a band pass band limited white noise, transfer function is h of omega is equal to 1 for omega naught minus w by 2 to omega naught plus w by 2. So now here the band pass band limited white noise, the range of the frequency is omega naught minus w by 2 to omega naught plus w by 2 and h of omega is equal to 0 otherwise. Consider a low-pass band-limited white noise and its power spectrum is Sn of omega is equal to n0 by 2 for minus omega naught to plus omega naught. And this is the power spectral density of the random process n of t. Next, find out the autocorrelation function of the band-limited noise process, band-limited noise. So, but we know that the power spectral density and autocorrelation function form a Fourier transform pair and inverse Fourier transform is Ryy of tau is equal 1 by 2 pi integral minus infinity to infinity Sn of omega into e power j omega tau d omega. But the power spectral density Sn of omega is n0 by 2. Substitute that value into here. We get Ryy of tau is equal 1 by 2 pi. So Sn of omega is n0 by 2 over the interval minus omega naught to plus omega naught into e power j omega tau d tau. So n0 by 2 is the constant that is written before integration. Integral e power j omega tau integration is e power j omega tau by j tau over minus omega naught to plus omega naught. So now here this within the bracket term substitute upper value and lower value of omega, we get the within the bracket term is e power j omega naught tau minus e power minus j omega naught tau by j tau. So using Euler identity, e power jx minus e power minus jx is 2j cos x. Using that expression, e power j omega naught tau, e power minus j omega naught tau is 2j sin omega naught tau. So simplifying the RHS term, we get Ryy of tau is equal n0 by 2 pi tau into sin of omega naught tau. So converting, find out the autocorrelation function of the random process y of t in terms of the sampling function. So in terms of the sampling function, now we are multiplying numerator and denominator by omega naught. We get n naught omega naught by 2 pi into sin of omega naught t by omega naught tau. Sin of omega naught tau by omega naught tau. Sin x by x is the sampling function. So therefore, Ryy of tau is equal n naught omega naught by 2 pi into of omega naught tau.